Hi everyone! In this video, I will show you how to perform hybrid search with Elasticsearch and a library called ranx. Hybrid search is a combination of two things: semantic search or KNN search and full text search. Here is how it works. We take a query, we feed that to the KNN search. Let's start with KNN, and at the end we get similar documents. We do the same thing for full text search and we get another set of documents. Now we take these two results and we pass them to the hybrid search system. In the end, we get a union of these documents and the scores will be different. The question that we need to ask is, how do we combine the results from KNN and full text search? Because basically, KNN search will have a scoring between 0 and 1, and full text search will have a different scoring. So maybe, for example, here the first document will have a score of 0.7, but here in full text search it might have a score of, let's say, 6.5. So you can see that the scales are not the same. The answer to this question is a fusion algorithm. Fusion algorithms are designed to basically combine two different sets. And one of the algorithms that is used a lot in hybrid search is Reciprocal Rank Fusion. If you click on this link, it will take you to the documentation of Elasticsearch that explains how RRF works. And if you click on Fusion algorithm, you will see a list of all algorithms that exist. And if you want, you can play with different ones. But in this video, we will focus on the RRF algorithm. I also want to mention that with Elasticsearch, if you want to use this algorithm, you need to have a paid license. As you can see here, I took this from their website. Here in the free tier, here I have highlighted the RRF option. You can see that it is not available. Even in the platinum subscription, you cannot use it. You need to have at least enterprise subscription to be able to use this algorithm. And for me, I didn't have this license, so I was stuck. This is why I did not include this in the course. Thankfully, I found this amazing Python library. It is called ranx. If you click on it here, it will take you to their website. And ranx is obviously free and open source, and it also implements all these fusion algorithms. So we are going to use ranx to apply the hybrid search. Here we are in this video, we are going to combine between Elasticsearch and ranx. With Elasticsearch, we are going to perform semantic search and full text search. The output from these two search methods will be then given to ranx, and at the end, ranx will fuse those lists of documents and give us the final result. Now let's go to VS Code in order to implement this. Make sure to open the notebook number 29 and follow along. Here, if you want, the team at Elasticsearch have created this tutorial, and in one of the steps they talk about hybrid search. If you want to read more about this, make sure to click on this link. Otherwise, we start by connecting to the Elasticsearch cluster, but before that, make sure that the container is running. For that, make sure to run the following command: docker start Elasticsearch. If you see this, it means that the container is running. And to confirm, go back and run this cell. So it takes some time to connect, but eventually we will be able to connect. Good. So now we need to prepare the index. Because we are going to use KNN search, we need to add explicitly a field with the type dense vector. This field will store the vector after converting the text by using an embedding model. So let's create this index with this field. Now we are going to use an embedding model. And like the previous tutorials, I'm going to use the all-mini-lm embedding model because it is small and everyone can run it, even if you don't have a GPU. For that, we use the sentence transformers library, and here you specify the name. I have already downloaded this model, so this cell will not take a lot of time, but for you, if you run this for the first time, this process will take a little bit of time because you need to download the model. And here in this step, we are going to check if you have a GPU. If you have it, then we are going to use it. So here, as you can see, I got CUDA, which means that I have a GPU. And now I'm going to pass the model to the device. Great. Now we need to load some documents. I have this astronomy.json file. Let me open it for you so that you can see what it contains. It contains 10 documents that talk about topics related to astronomy. I am going to use these documents as an example. And here in the embedding documents section, we are going to loop over all documents and we are going to insert them in the index with the help of the bulk API. And here, this is how we use the model from Hugging Face. We just call the encode method. It expects a string, which is the text in our example, and it's going to return a list of numbers, which is our embedding. So if we run this, you can see that with 10 documents, it goes very fast. And even if you have a CPU, this shouldn't take a lot of time. Now we can also verify if everything went well. So here I'm going to retrieve all documents and I'm going to look at if I have the embedding. And yes, you can see that this is the content. We transformed this from text into a list of numbers. So this is the embedding, and it means that we were able to transform this correctly. Now let's continue. And here also we can verify the mapping. And yes, we have the embedding field and the dimension is 384. Awesome. So this is just a preparation. Now we have documents in the index and they are embedded. Now we will start with KNN search. So here is our query. We need to embed it. And in the KNN parameter, we make sure to specify where those vectors are stored. And in my case, they are stored in the embedding field. Here we need to pass the embedded query and finally the final number of documents that we want to return. If I return this, I get 3 documents, but I can go up to 10 documents because that's the number of documents that I have in that JSON file. Now let's look at the documents in order to look at the scores. You can see that my question was about what is a black hole, and there is only one document that talks about black holes. And as you can see, KNN search was able to retrieve that document and it gave it the highest score. The score is 0.88 and the second document has a lower score of 0.66, which means that it works. And we can do the same thing with full text search. And here is how we do it. We don't use KNN. Instead, we use the body or we use the query parameter. You can use both syntax. And here we specify match because we are doing full text search, and we specify the field. The text in my case is stored in the content field and I pass my query. So this gives me 6 documents. If I look at the scores, you can see that we have a different scale. This is what I was talking about in the slides. You can see that, yes, we got the same document which talks about black holes, but the score is very high. It's 6.23. Before it was 0.88. This is the problem with these two search methods, but luckily there is a way to combine these lists of documents, even though the scores are different. But you can see that here again with the full text search, we got documents that are not related, but there is a parameter that we can add here alongside the query. It's called minimum should match. So here we specified 80%, which means that we need to retrieve documents where 80% of the query is present in those documents. When I do that, I get only one document because the term black hole does not appear in the other documents. And that's why we were able to filter all those documents. And now instead of getting 6 documents, we get only 1. And now, after seeing how to implement KNN search and full text search, let's merge them together. So here, this is the paid solution, which is, I would say, the easiest, because here's how you do it. So in this search method, we provide the KNN option, the query option, and so these are the two things that we have done in the previous cells. And on top of that, we add rank. And here we specify the fusion algorithm, which is RRF. But if you try to run this, if you are like me and running Elasticsearch locally, you will get this exception. So here it says the current license is non-compliant for this algorithm, which means that sadly I cannot use it. But if you are using the paid version, and if you work at a company that is using the enterprise version of Elasticsearch, you should be able to use this method, and it's the easiest, because after this you get your documents back. I will keep this in this notebook, even though I am not going to benefit from it. But in the next cells, we are going to look at this free solution. As I mentioned in the slides, I'm going to perform both searches independently. I have the query. First, I will perform the keyword searching, and after that, I will perform the KNN search, and I will store the results. So when I do this, I get one document back from the keyword search and 5 documents from KNN search. So this is the first step. Now the second step is to install ranx. It's easy. Just run pip install ranx and you will get it. Now with ranx, you need to use these run objects. Click on this link in order to read more about it. It will take you directly to the documentation. But basically, for each query, we need to provide it an ID. So here I gave it a simple ID because there is no other query. And here for each query, you need to give the document ID and the score. So if I run this and look at the keyword run dictionary, I should be able to get just one. As you can see, so we have one dictionary or one key, and here are the documents. Remember that on Elasticsearch, each document has an ID. So this is the ID of that document and the score that we got after using keyword searching. The same thing applies to KNN search, but this time we will get how many? 1, 2, 3, 4, 5 documents. Okay, so this is the run object that ranx expects. Now we use the fuse method. We provide the list of runs. Here we have just 2. We have the keyword search and the KNN search. So we put them in a list, and the method is RRF. If I run this, I get the combined run, which is a fusion of these 2 documents. And we can verify this. So after that, we can sort the scores like this. And as you can see, the scores are different. Before in KNN search, the highest score was 0.88. And with full text search, the score was 6.2 something. But now you can see that the score is very low. It's 0.03 because, as I told you, ranx, even though the initial scores were different, ranx or any fusion algorithm is able to work with this kind of data. And the most important thing is that we get another list with some scores, and we can verify that this document with the highest score is the one that talks about black holes. But before that, let me just take a look at the size of each list. We know that with KNN search we got 5 documents, and with keyword hits we got 1 document, and the final size is the union of these documents. And here you can see that we got 5. We didn't get 6 documents. Why? Because here in let's see, in the keyword list, we have this document is the one that talks about black hole, and the same document is present in the KNN list. So when we do the union, we get 5. But let's say that this document was different. In that case, the final list will be equal to 6, and we can verify this. So here, if I want to combine the hits, let me take this code, let's put it here, And instead of doing KNN hits plus keyword hits, I will just print the IDs. So let me do that quickly. Print the ID. Okay, let's print the ID and the score. So for KNN, remember 0.88 is the top document, and we can do the same thing for the keyword hits. So I can come here and search for keyword hits. And as you can see, this document is the same as this one. So doing union will give you the same thing. Great. So let me remove these because I don't need them. And here, let's look at the scores. So the scores have changed, but the document that talks about black holes is still at the top. So here in the first part, I am merging the documents. After that, I am going to print that. So let's look at this. So here for each document in the sorted results, which is right here, we are going to get the document ID as well as the score. Here they are. We get the document ID and the score. And we are going to search for this for the document ID in this dictionary. So if we get that, we are going to print the document. And as you can see, black holes is the first document and it has the highest score. And the other one, dark matter or galaxies, they have very low scores. We arrived at the end of this video. I hope that you enjoyed it. See you in the next one.